In this video, we are going to discuss force and laws of motion. And this is the NCERT 9th class, chapter 9. So we will be discussing force and laws of motion, and we will be only discussing the important concept in it. We will not go in detail. So let's start. Uh, in the previous chapter, we discussed about the motion. Now, we have not yet discussed what causes motion. Why does the speed of an object changes with time? A ball on the ground, when given a small hit, does not move forever. Such observation suggests that rest is a natural state of an object. This remained a belief until Galileo and Isaac Newton developed an entirely different approach to understand motion. So before, a natural state used to be thought as a state of rest, but Galileo and Isaac has developed some other concept of motion which we are going to discuss in this video. Pushing, pulling, hitting an object changes the state of motion. Pushing, hitting, pulling, this will always bring an object in motion. Let's talk about first balanced or unbalanced force. If a block is pulled from the both sides, this is a block, it is pulled from the both sides. Block will not move with equal forces. If the equal forces are applied, block will not move, and such forces is called balanced forces. Now let us consider a situation in which the opposite forces of a different magnitude pulls the block. Thus the forces are not balanced, and unbalanced force acts in a direction the block moves. Suppose now forces are unequal. Suppose there is a 10 Newton force and there is a 5 Newton force. So this is unbalanced force, and this ultimately led to the motion of the block in the directions of unbalanced force. Now the first law of motion we will discuss here. The Isaac Newton developed 3 laws of motion. So in this video we will learn the three laws. The first law is Newton further studied Galileo's idea on the force and motion and presented 3 fundamental laws that governs the motion of an object. The first law states that an object remains in a state of rest or a uniform motion in a straight line unless compelled to change that state by an applied force. So that means the natural state of an object is either at rest or at a uniform motion in a straight line, and the object only changes its state when a force, unbalanced force is applied on it. The force will be unbalanced. In other words, all objects resist to change in their state of motion, and this resistance is called inertia. We will discuss this. Now, who is a Galileo? He is a scientist, was born in Italy, and in 1586 he wrote the first scientific book, A Little Balance, La Balanstica, in which he described the Archimedes method of finding relative density or specific gravity of a substance by using a balance. Galileo was also a remarkable craftsman. He developed telescopes. In his book Starry Messengers, on his astronomical discoveries, Galileo claimed to have seen mountains on the moon, the Milky Way, made up of tiny stars and four small bodies orbiting Jupiter's moons. Small bodies are moons of the Jupiter. Using his own telescope and through his observation on Saturn and Venus, Galileo argued that all the planets must orbit the Sun, not the Earth, contrary to the what was believed at that time in Europe. So he was a great scientist. Let's talk about inertia and mass. There is a resistance offered by an object to change the state of the motion. Either the state can be rest or in a uniform motion in a straight line, and there is a resistance in that object. If it is at rest, it tends to remain at rest. If it is a moving, it tends to keep moving. This property is called inertia. In Hindi we call it jadatva. Quantitatively, the inertia of an object is measured by the mass. So inertia is a natural tendency in an object to resist a change in its state or rest. The mass of an object is a measure of the inertia. That means more is the mass, more will be the inertia, and more energy, more unequal force will require to change its state of motion. If less is the mass, less is inertia, and less unbalanced force will be required to change its state of motion. Not a state of motion, just a state. It can be rest or it can be uniform motion. Now, what is the second law of motion? Let's discuss this second law of motion. These are simple laws of motion. So, momentum was introduced by Newton. The momentum is also described by P of an object is defined as the product of a mass and velocity. The momentum is a multiplication of mass into velocity of an object. The second law of motion states that change in momentum of an object is proportional to the applied unbalanced force in the direction of the force. So this is if moment is changing, why it will be because of applied unbalanced force. So this is what the second law of motion is. The rate of change of momentum is directly proportional to the applied force. These are some mathematical derivation about the momentum, and force is the mass into acceleration. Now, what is the third law of motion? The third law of motion states that when one object exerts a force to another, the second object instantaneously at the same time exert a force back on the first object. These two forces are always equal is magnitude but opposite in the direction. This is called the third law of motion. That means the two opposing forces are known as actions and reactions. However, it must be remembered that the action and reaction always act on a different object simultaneously means at the same time. And suppose in third law simply says action reaction is not thing like we normally understand in daily life. If there will be action, there will be a reaction. It is not like that. in the construct of in the in this in this context uh, context, the action reaction simply means the exerted force. If suppose exerted force is 10 Newton and same exerted force will be there if this 10 Newton is pulling and this will be again pushing. We will this understand this concept later, but it's not like action reaction, but simply the action reaction is not generally we mean by, they are basically the same force which is in opposite direction, the forces which are same and they are in opposite direction. uh, in a general form, suppose there are two objects. If this object is applying a force of 10 Newton on it, attraction force, and an action reaction says this object will also apply a 10 Newton force in its direction, so these two forces will be equal and in opposite direction. Two opposing forces, this is why the two opposing forces which are equal in magnitude are called action and reactions. This concept is highly misunderstood by the words action and reactions. Now I think I have cleared it. The bullet exerts an equal and opposite force on the gun. This results in the recoil of the gun. Since the gun is has a much greater mass, the acceleration on the gun is much less than the acceleration on the bullet. So the gun has a weight, has a mass. So for its momentum, the more force is required. As its mass is less, so less momentum is required. So when the force, when it shoots the bullet, it's apply action reaction happens. See, the energy that goes straight, the force that is applied straight on the bullet, an equal amount of force is applied backward on the gun. Since the bullet has a small mass, so its momentum is high, and it has a more mass. The force do not changes its motion much. It only recoils a little bit. Now conservation of momentum is always conserved. It transfers from one thing to another things, but always conserves. As a result, this is the ideal this ideal collision experiment. We say that the sum of the momenta of all the object before collision is equal to the sum of the momenta of an object after collision, provided there is no external unbalanced force acting on them. This is known as a conservation of moment. This statement can alternatively be given as the total momentum of a two object is unchanged and conserved by the collision. Suppose there are two objects, they collided, and after the collision the moment remain conserves. That means suppose this is going to this direction, it is coming from this direction, it conserves, and they goes in this direction, it goes to this direction. Suppose its momentum is x, suppose its momentum is 2 and its momentum is suppose of 3. Now after that it collides, after collision its momentum, suppose it gains forces from it and its momentum increases. Suppose its momentum will be just 4, and at the conservation of momentum will be as per the conservation law, its momentum will be 1, so that the initial moment, which is a 5, will equal to the final momentum 5. This is provided by the no external unbalanced force is applied on it. Nothing will be any other force should be there. So we are almost finished this chapter. Conservation laws such as conservation of momentum energy, angular momentum, angular momentum and charge, etc., are considered to be fundamental laws in physics. So this is a one important thing. The laws of conservation of moment has been deduced from the larger number of observation and experiments. This law was formulated nearly 3 centuries ago. It is interesting to note that no single situation has been raised so far in which contradicts this law. The several experiences to everyday life can be explained on the basis of the conservation of moment. Let's recap this chapter. The first law of motion says an object continues to be a state of rest or the uniform motion in a straight line unless acted upon by the unbalanced force. Unbalanced is the important word. Cannot be balanced. In case of balance, there will be no change in state. The natural tendency of an object to resist to change to their state of rest or uniform motion is called inertia. And mass of an object is a measure of the inertia. More is the mass, more is the inertia. Force of friction always opposes motion of an object. In next chapter we will also discuss the friction. In next, maybe in 10th class. Friction is opposing force which opposes the motion. Second law of motion, the rate of change. What is the second law? The rate of change in the momentum. Momentum is equal to mass into velocity. Rate of change of momentum of an object is proportional to the applied unbalanced force on it. And the SI unit of force is kilogram meter. Force is MA na. This is F equal to MA. M is a mass, A is a acceleration, mass is kg, acceleration is a meter, acceleration is again velocity upon time. Velocity is again distance upon time. So this is how this time goes up. T square will be there and it goes again up, it will be T minus 2. So it will be kg. D is a distance which is in meter and second square which is time minus 2. This is how this unit comes. Okay. It is also known as a Newton, represented by the N. A force of 1 Newton produces an acceleration of 1 meter per second square of an object of 1 kg of mass. Suppose this is a 1 kg of block. So how much is a 1 Newton force? Produces an acceleration. Suppose an force is provided on it and this accelerates in 1 second about a 1 meter, and in second then 1 meter more. So suppose a 1 kg of a body, when applied by a force, external force, in 1 second it accelerates 1 meter, and in next second it again accelerates 1 meter. So its current speed will be 2 meter per second, and in third second its acceleration will be, its speed will be 3 meter per second. So this applied force through by which the acceleration is happening is equal to the 1 Newton. 1 Newton. This acceleration is in a frictionless surface. Frictionless surface. Frictionless surface. Okay. And just to experience in a day-to-day life, 1 Newton force is roughly equal to holding an apple. Holding an apple in a hand. Suppose I am holding an apple in a hand, in a straight hand. So the force which I am applying on it to like maintain its position, is roughly equal to the 1 Newton. The momentum of an object is a product of mass and velocity and has the same direction as the velocity. Its unit is kg per meter square. Third law of motion says every action there is a equal and opposite reaction. That means if there is a 10 Newton force applied in this direction, and there will be a 10 Newton force applied in opposite direction also. So this is action reaction. Same force in opposite direction is applied. Acted on the two different bodies. And in isolated system where there is no external force, the total momentum remains conserved. Okay, here the chapter ends. Thank you for watching this video.